Okay, in this video we're going to look at one of the enhancements to SOLIDWORKS simulation for 2023 and newer versions, which is a whole new algorithm for the Underconstrained Bodies tool. Now, this will be useful for you if you've ever encountered messages about your model being unstable, excessively large displacements, or just an outright solution failure. So first we'll look at an example that will take advantage of some of the enhancements of the new tool. I'm using right now a SOLIDWORKS Simulation Premium license, but these updates are also available in SOLIDWORKS Simulation Professional. And I have an example that has quite a bit of contact. So I can see here with the interaction viewer, I have a sliding contact with a bolted joint. I have this spherical ball that's captured by the tie rod end here. And then I have some bonding, and I have a piece that's also held together with just pin connectors. But I happen to know the model's unstable. So if I want to quickly visualize this, I can use the updated Underconstrained Bodies tool. Click Calculate. And very quickly, I'm presented with information about what, if any, bodies are under constraint. So in this case, 3 translations and 3 rotations mean this body was completely detached, probably wasn't bonded here when it was supposed to be. And basically for 2023 in Simulation Professional and higher, we have the ability to do this now for problems involving contact, sliding contact, bolts, and so on. Historically, this tool only worked if everything was all bonded. So we can see in the What's New documentation that we can now include contact interactions and bolt connectors. This is made possible by a new algorithm based on a technique called singular value decomposition. And it's also very fast, citing that for models that take hours to run, we can detect the rigid body modes in only seconds. This is really held up in my testing as well. So once we identify that problem area, we can go in and either place an additional local interaction to bond things, or maybe edit our global interaction to adjust the gap range for bonding. Okay, so even if you're using a lower level license of SOLIDWORKS simulation, such as the simulation that's available in SOLIDWORKS Premium or SOLIDWORKS Simulation Standard, you can still use the legacy version of the Underconstrained Bodies tool, which is going to work great for components that are all bonded together. Whenever we don't have any contact interactions in the model, we can use this to calculate which bodies have any remaining degrees of freedom. It may also just solve a little bit slower than the new algorithm. But here we can see it's quickly able to identify the body that was loose on this model, which is the gusset. Then we can drill down with additional tools like the interaction viewer, which prior to these updates was my go-to tool for determining areas that may require some additional interactions. And we can see a conspicuous lack of bonding around that gusset. When we zoom in more, we can see that there was some kind of gap there, maybe for a weld gap or otherwise. We could correct that a number of ways, either by extending those faces to initially contact, by adjusting our global contact and its range for bonding, which we have to be careful of because that will bond many different things together if we start increasing that too far. Or we can always go in and place local interactions to bond various faces together, even across a small gap. So I can essentially bond using the right click and select other tool, these faces together. Then if I were to run that Underconstrained Body tool again, we'd likely see that there's no underconstrained bodies, but I'll just go right ahead and run the full analysis. And we can see we get some what appear to be reasonable stress results. Now, as a fallback method, if you do have a problem involving contacts where you're still worried about some under-constrained body, and you don't have access to this updated Under-Constrained Bodies tool, either because you're using an older version of SOLIDWORKS or you don't have the Simulation Professional or higher license, you could also try enabling soft springs through the solver options, and that should hopefully allow the study to solve to completion, likely with an excessive displacements warning. When you get that warning, you'll just want to click No, and then you should hopefully see a very high displacement on one or more of the bodies. So you want to be sure you're on automatic deformation scale, and this will scale down the deformation so you can actually see which body is under constrained. If you were to go to true scale, you'd probably see this body fly right off the screen. So this is a fallback method you can use to stabilize the problem to try to visualize which bodies are under constrained. And I'll just note that even though the Under Constrained Body Tool new algorithm is only available in Simulation Professional and higher licenses, there's some other across-the-board improvements that will benefit even SOLIDWORKS Premium and Simulation Standard users, such as enhancements to the bonded interactions, a new adjustable scale factor for the accuracy of the contact calculations, and solver enhancements across the board for the FV Plus or iterative solver. So we'll also link these enhancements in the description below so you can explore them on your own. So I can't emphasize enough how useful this new Under Constrained Bodies algorithm can be if you're dealing with complex assemblies with a lot of contact. That was historically the biggest limitation of this tool, and so it would always kind of take a back seat for my usage compared to things like the interaction viewer. But now that this is available and it's so fast, it'll be a tool that I'm using early on and throughout my simulation setup. Let us know in the comment section down below if you have any questions and what type of content you'd like to see next.